Okay, we are going to talk about hydrogen bonding next. Okay, now it's called hydrogen bonding or hydrogen bonds, whatever you want to call it. Well, let me just write this. It is not a bond. All right, it's called a hydrogen bond because it is the strongest intermolecular force. So I guess that earns it the title bond. I'm not really sure. Maybe it's just an old name. But it is not a bond, okay? So I'll show you what is a hydrogen bond and what is not a hydrogen bond. First off, this is the strongest intermolecular force, like I said. And what it is, it's a special type of dipole. And here's the key to what we need for hydrogen bonding. We need in the molecule an NH bond, an OH bond, or an FH bond. Okay. Why those three? Well, if you think about where these are on the periodic table, they're all close. There's fluorine, and then oxygen is next to fluorine, nitrogen is next to oxygen. Okay, these all have high electronegativity. They have high electronegativity, which means they are very polar bonds. I could just say they make highly polar bonds. And also, they're small atoms. I don't know why I put that there. Small atoms means that they can get close together. Well, what does that mean? Well, just think about two magnets. If you can get two magnets close together, they're very difficult to pull apart. They hold very, very tightly. Get those same two magnets just a little bit further apart, and they're very easy to separate. Same thing going on here. Nitrogen, oxygen, fluorine, all three are small. Hydrogen is small. So these groups can come very close to each other, and therefore they have a very high attraction to each other. So let's look at a hydrogen bond. It looks just like a dipole does. But the key is that you got to have those three groups. Okay, you're looking for one of those three groups in the molecule. Okay, so there's our water molecules. Remember, oxygen is going to have a little bit of a negative, and these hydrogens are going to be a little bit positive. And what does that mean? That means there is a hydrogen bond between the two molecules. That is the H bond, or the hydrogen bond. Okay. This or this are covalent bonds. What is that? Covalent, there we go, bonds. They are not intermolecular forces. So often I get students drawing arrows to the bond, that covalent bond that holds the water molecule together and says, oh, that's the hydrogen bond. Yes, that is a bond to a hydrogen, but it is not a hydrogen bond. The hydrogen bond is the intermolecular force between two different water molecules in this case. Okay. So let's talk about hydrogen bond and how strong it is, and let's talk about whether or not it's important. Okay. So I'm going to draw a little graph here. So first, let me give you some examples. So you got to have those three groups, the NH, OH, or FH. Okay, I'm going to give you one little hint. There is exactly one molecule that has an FH group in it. Both fluorine and hydrogen only want one bond. Okay, once they form one bond, they won't bond to anything else. So the only molecule with an FH bond in it is an HF. That's the only time you're going to see that FH. So everything else, you are looking for an NH or an OH. So water obviously is already up there. CH3OH, CH3NH2. Okay, you gotta have that NH or OH. That's what we're looking for. And then again, that guy there, but that's the only time you're going to run into that. So let me draw that graph I was just mentioning. And we're going to plot boiling points. It's going to be versus molecular weight, but that doesn't really much matter. Okay, so here is our plot. And the only thing that's really important here is we're going to have boiling point, and it's going to be a relative curve. Okay, so I'm going to start off by plotting H2S right here. Okay, boiling point for H2S, and I'm not going to worry about the numbers. You'll understand hopefully in a second. There's H2S. Now, right below S on the periodic table is Se. Okay, so let's plot H2Se. There's the boiling point for H2Se. Okay, a little bit higher than sulfur, or than H2S. Okay, now we plot H2 TE. Why TE? Well, TE is right below SE. Okay, so we have this nice trend. So higher, that's the biggest of the three, highest molar mass. So it has the highest boiling point. Okay, H2S, smallest, lowest boiling point. And just for a point of reference, let's pull out that ruler again. It's H2TE, its boiling point is just about 0. And 0 degrees Celsius. So, and this graph again is not going to be to scale. Where's H2O go? Why would I bring up H2O? Well, H2TE, whoops, H2TE right there. Then above TE on the periodic table is Se. Then above Se on the periodic table is S. What's above S on the periodic table? Oxygen. So we need to plot H2O. Are we going to plot it down here somewhere? No. Because we all know the boiling point for water is well above freezing, well above 0 degrees Celsius. Again, not to scale, but there it is. What is the difference? Guess what? It's the type of intermolecular force. All three of those have dipole. And what about water? Hydrogen bonding, which I just abbreviate as an H bond. Okay. Hugely important intermolecular force. Water wouldn't be liquid without it. H2S, if you've ever been to a volcano, you smell H2S, it's a gas. Okay, we would predict water would be somewhere down here as a gas also. It's not. That's why we have liquid water on our planet. Okay. Other things that hydrogen bonding, H bonding is important for, just briefly. H bonds, they hold your and everyone else's DNA together, literally. Hydrogen bonding between the opposite base pairs holds DNA together. And it can come apart relatively easily, so DNA can be copied, and then it goes right back together, kind of like a little zipper. Okay. What else? Holds your, oh my gosh, your proteins together, okay? Proteins have very specific three-dimensional structures. Without those structures, they do not function in your body correctly. So when you get a fever, your body is trying to disrupt the hydrogen bonding in the virus or the bacteria and disable its enzymes, which are proteins, and kill the bacteria or the virus by warming it up, and that can interfere with the hydrogen bonding, okay? And it tries to do that before it interferes with your brain, the proteins in your brain. Sometimes that doesn't happen. That's too bad. Anyway, that's it for hydrogen bonding.